We've seen many different types of numbers in maths. Natural numbers, whole numbers, integers, fractions, and in the previous lessons, we also learned about terminating, non-terminating, repeating, and non-repeating decimals. That's a lot of numbers. Luckily, we can classify all of these numbers into just two categories: rational and irrational numbers. In this video, we'll see how we can group all of these numbers into these two categories. Earlier, you learned that numbers can have two types of decimal expansions: terminating or non-terminating. Terminating numbers include numbers like the integer 2, fractions like 1 by 4 or 2 by 5, and square roots of perfect squares like the square root of 4 or the square root of 16. And under the non-terminating group, we have two types of decimal expansions: repeating and non-repeating. We also call them recurring and non-recurring. Repeating numbers include fractions like 1 by 3, which is equal to 0.3 bar, 1 by 11, which is equal to 0.09 bar, and so on. And non-repeating numbers include all the square roots of numbers which are not perfect squares, such as the square root of 2 or the square root of 3. For non-repeating numbers like these, we can never find the exact decimal expansion because the decimal never ends and the digits after the decimal are random. So even though repeating numbers do never end, the digits after the decimal show a certain pattern. No such pattern exists in non-repeating numbers. So we can find the exact decimal expansion of all numbers except non-repeating decimals. So there are actually numbers whose exact decimal values can never be achieved. That doesn't make sense, does it? And that's exactly why mathematicians started calling these numbers irrational numbers. In English, when we say something is rational, it means it is logical or that it makes sense. So something that does not make sense is called irrational. Hope you now understand why non-repeating numbers are called irrational numbers and all other numbers are called rational numbers, and why terminating and repeating decimals are rational numbers and non-repeating numbers are irrational numbers. Let's now quickly summarize what we've just learned. All numbers whose decimal expansions are terminating or repeating are called rational numbers. Numbers whose decimal expansions are non-terminating and non-repeating are called irrational numbers. And all the different types of numbers can be placed under just two categories: rational and irrational. Here's the chart we had seen in the earlier session for fractions and square roots of numbers. Take a look at it for a few seconds and try to answer these questions. Are all fractions rational numbers? Yes. Why? Because the decimal expansion of fractions is either terminating or repeating. Are all square roots irrational numbers? No. Why? Because some square roots terminate and some do not terminate. So the square roots of all the perfect squares of natural numbers, like the square roots of 4, 9, and 16, are rational. However, the square root of 2 or the square root of 3 are irrational. If you got the answers right, well done. Now, so far we've been learning that the square root of certain numbers are irrational. But are these the only examples of irrational numbers? Ever heard of the number pi? Pi we use in geometry or mensuration. Pi is also an irrational number.